Before starting the next lesson, try this warm-up. Evaluate these expressions. So this will test whether or not you remember what an exponent means and how to use them. So pause the video, try these, and then check back in, and I'll take it up. So remember, pause the video. I'm serious. All right, here you go. So hopefully you remembered that an exponent just tells you how many times you multiply this number by itself. So 2 to the exponent 3, or 2 cubed, is just 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. If you have an exponent on a negative number, that means that negative number is multiplied by itself, in this case, 4 times. So minus 2 times minus 2 is positive 4, times minus 2 is negative 8, times minus 2 is positive 16. Now here I have a negative 2 to the exponent 4, just like I did here, except there's a difference. This has no brackets around the minus 2. So this is different. In part B, the exponent was on the brackets, so everything in brackets was multiplied by itself 4 times. Here the exponent is not on brackets, it's just on the 2. So it's just the 2 that gets multiplied by itself 4 times. 2 times 2 times 2 times 2, that's 16. And then you have that minus sign in front, which makes the whole thing negative 16. So pay attention to brackets or no brackets, because it can change your answer. Here it was positive 16, here it was negative 16. So just watch out for that, whether there's brackets or no brackets in your exponent question. Down here in parts D and E, I have same idea except fractions. A lot of people freak out when they see a fraction, but fear not. It's really easy. Whatever's in brackets, in this case, is multiplied by itself 3 times, so 1/3 times 1/3 times 1/3. Multiplying fractions are easy. Just multiply the top numbers together. 1 times 1 times 1, well, that's 1. And then multiply the denominators together. 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times 3 is 27. So 27 is my denominator. 1 cubed on the top, 3 cubed on the bottom. Here we have 7/8 squared. Well, 7 squared is 49, 8 squared is 64. So 49 over 64 is my fraction. So hopefully this just got your brains in gear for working with exponents. Because the start of our first unit on exponential functions deals with exponent laws and rational exponents. This would have been stuff that you saw in grade 11, but we're going to revisit it here just to make sure you're on the right track. So our goal for this lesson is for you to be able to apply the basic exponent rules to questions that contain both integer and rational exponents. So we'll talk about what those are and how you use them. And then you should also be able to rewrite exponential expressions in radical form. So we'll talk about what that is, remind you of what that is, and then we'll hopefully have you experts in exponents by the end of this lesson. First, I just want to start off with some terminology. A lot of people get the words power and exponent confused, so I just want to remind you of what that is. So when you see something like this, we have 2 with an exponent of 3, that whole thing is called a power. This up here is the exponent. This part here, the 2, is called the base. So a lot of people will misread this and they'll say 2 to the power of 3, but technically you're misusing the words. It's 2 to the exponent 3. That's what the power is. So the power is 2 to the exponent 3. The power has a base of 2 and an exponent of 3, in other words. Okay, so there's the words base, power, and exponent. You need to know what they mean, and you need to understand what the different parts of the power are, as I will use those words going forward. I want to spend some time just reviewing the exponent laws. Now, you would have seen these in grade 11, so I'm not going to go through a full explanation of how these rules are derived. But if you need that explanation of why the rule is the way that it is, just send me an email and I can explain it in more detail for you. So let's just recap. Here we have multiplying powers with the same base. Well, the rule is you add the exponents together to simplify into a single power. If you're dividing powers with the same base, you can simplify to a single power by subtracting those exponents. If you have a power of a power, so by that I mean the base of this power is a power itself. So a power of a power, simplify that into a single power by multiplying the exponents together. If you have a power where the exponent is 0, your answer will always be the same. It will always be 1. And if you have a negative exponent in your power, you can simplify that by turning the base into its reciprocal and the exponent into a positive one. Now, just a couple notes. The rules for multiplying and dividing powers only works if the powers have the same base. Also, for any of these rules to work, the base must never be 0. Otherwise, your answer is just 0. You don't actually have a power. Now, I'm going to work through some examples that illustrate these exponent laws. If you need to write this down to refer back to it, for now, that's fine. But the goal is that you will have these rules memorized and you'll be fluent in working with exponents by the time you get to the unit test. Okay, so here's my first example, simplify. So when I say simplify, I mean turn these expressions into a single power with a positive exponent. Okay, so if you want to pause the video and try this on your own, if you're feeling confident enough, you can do that and then just check back in to see how you did. Otherwise, keep following along with me. Okay, so here I have two powers. These powers have the same base. They both have a base of 2, and I'm dividing them. So remember my rule, I can subtract the exponents. So this simplifies to 2 to the exponent 7 minus y. I can't simplify 7 minus y because I don't know what the value of y is, so I have to stop there. Here, I have a negative exponent. The numerator is 1, so I can rewrite this whole thing as 1 over 5 to the exponent negative 2. It's the same thing. So if I have a negative exponent, I can simplify this by taking the reciprocal of the base. So instead of 1 over 5, it's 5 over 1, or just 5. And then my exponent, instead of being negative 2, is now positive 2. So this simplifies to 5 to the exponent 2. Here I'm multiplying powers with the same base. These both have the base of x. If I'm multiplying them, I add the exponents. 3 plus 2 is 5. So this simplifies to x to the exponent 5. Now this example is a little trickier. I have lots of different exponents here. So if I look inside the brackets, I have two powers. They're multiplied together. However, the bases are not the same. These don't have a common base. So I cannot use my rule where I add these exponents together. That just wouldn't make sense because the bases aren't the same. I can't do that. So I have to leave this alone. Now this exponent of minus 2 appears right beside the brackets. So that means this whole thing in the brackets has an exponent of minus 2. Now the rule for a negative exponent is to take the reciprocal of the base and make the exponent positive. So I can rewrite this as 1 over x squared y cubed to the exponent positive 2. So now I have this exponent of 2 on both these powers. So x squared to the exponent 2 times y cubed to the exponent 2. I have powers of a power here. So x squared to the exponent 2, multiply 2 times 2 is 4, so I have x to the 4, and then y cubed to the exponent 2, well, 3 times 2 is 6, so that's y to the exponent 6. So I end up with 1 over x to the exponent 4 times y to the exponent 6. Some people might want to try adding these exponents together, but remember, these powers do not have the same base, so I can't use that rule here. I'm done. This is as far as I can go. This one here, 3 over b squared, all of that to the exponent 4. So if you have a fraction with an exponent, that means the exponent applies to the numerator and the denominator. So I can write that as 3 to the exponent 4 over b squared to the exponent 4. Now 3 to the exponent 4 is just 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So I have 81 in my numerator. B squared to the exponent 4, that's a power of a power, so I multiply the exponents. 2 times 4 is 8. So I have b to the exponent 8 in my denominator. For this last one, I have brackets multiplied by brackets, so that means this whole thing is multiplied by this whole thing. Now I know the rules for multiplying powers is they have to have the same base in order for me to simplify them. So I'm going to go through and just highlight. I'm going to call them like terms, but they're not separate terms, but hopefully you know what I mean. So minus 6 and minus 4 are like each other. They can multiply. M to the exponent 3 and m to the exponent 2, those are powers with the same base, so I can multiply those. And then n to the negative 2 and n to the 3 are powers with the same base, so I can multiply those together. So really, I just have to go through and I can only multiply the powers with the same base. Negative 6 times minus 4 is positive 24. M to the 3 times m to the 2, add the exponents, it's m to the 5. Then n to the minus 2 times n to the 3, add the exponents, negative 2 plus 3 is 1. So n to the 1, or just n. So my final answer is 24, m to the 5, n. So hopefully you have a handle on simplifying expressions using those exponent rules for multiplying and dividing powers with the same base, power of a power, negative exponents, and we'll move on, try some more. These ones are a little more difficult, as you can see, just because there's more going on. So I want you to try these on your own. So I'd like you to pause the video, try them, and then you can check in and I'll explain my full solutions. So pause the video and try it. Okay, here are my solutions. So you can see I kind of color-coded things here so you could see what's going on. 4 times minus 1. Remember, there's no brackets here. So the base of the power is actually just the a, not the minus a. So this is like minus 1 is the coefficient in front of the power a cubed. So 4 times minus 1 is minus 4. A to the 4 times a to the 3. 4 plus 3 is 7, so a to the 7. B to the 3. Okay, so that's where I got this numerator from. Now I look at the denominator. A to the 5, b to the 6 times b to the 2. Add the exponents, that's where the b to the 8 comes from. Now I still have powers with the same base in my numerators and denominators. So a to the 7 divided by a to the 5, I subtract my exponent. 7 minus 5 is 2. And then b to the 3 divided by b to the 8, 3 minus 8 is minus 5. Now this exponent is negative, so I can simplify this by turning it into a positive exponent with the reciprocal of the base. So if b is the numerator, the reciprocal would have it in the denominator. So that's why I wrote it like this. Over here, I start with this negative exponent. So I know a negative exponent can be turned to be positive if I take the reciprocal of the base. So whatever's the numerator becomes the denominator, and whatever was the denominator becomes the numerator. So I have the reciprocal of my base with a positive exponent now. Okay, now this exponent applies to everything inside the bracket. So c to the exponent 3 to the exponent 2, power of a power, multiply the exponents. 3 times 2 is 6. 2 to the exponent 2 is 4. A squared to the exponent 2 is a to the 4. B to the exponent 2 is b squared. So that's how I came up with this. Similar over here, a cubed to the exponent 3 is a to the 9. B squared to the exponent 3 is b to the 6. C to the minus 4 to the exponent 3 is c to the minus 12. So power of a power, you multiply the exponents. Okay, no more power of a power. Now I am just going to multiply numerator times numerator and denominator times denominator. I've just kind of changed the order so that I have it in the order A, B, C, just because I like that better. So a to the 9 times b to the 6 times c to the 6. That's my numerator. My denominator is 4a to the 4, b to the 2, c to the minus 12. And now I see powers with the same base. So if I'm dividing powers with the same base, I subtract the exponents. 9 minus 4 is 5, so I have a to the exponent 5. 6 minus 2 is 4, so I have b to the exponent 4. 6 minus negative 12. A lot of people run into trouble here. Subtracting a negative, so that's the same as 6 plus 12, which is 18. Now, since when I simplify it, all my exponents are positive, that means they're staying in the numerator. So the only thing I have in my denominator is this coefficient of 4 left over. Okay, that's how I come up with this final answer. I'd like you to just at this moment, do a quick little investigation just to make sure you can use your calculator. So I'd like you to type each of these expressions into your calculator. Make sure you know where your exponent button is. Make sure you can type in these fractions as your exponents. So for example, 4 to the exponent 1 over 2. In my calculator, I would type it in like this. So that's how it looks on my calculator. So I would type 4. This is my exponent button. It looks like an upward pointing arrow. Yours might look more like x to the exponent y or something like that. So you type 4, your exponent button, and then make sure you put brackets around your exponent to make so that the calculator knows that it's the entire 1 divided by 2, the entire fraction that's the exponent, and not just the first number you type in. So any way you do it, you should get an answer of 2 for this one. Quickly try the rest on your own and make sure you get these answers. If you don't get these answers, then you need to ask for help or look up how to use your calculator properly. Most likely the issue is you're not putting brackets around your exponent. So try that, see what you get. Hopefully it's these. Now I want you to notice something. 4 to the exponent 1 over 2 is 2. 9 to the exponent 1 over 2 is 3. 16 to the exponent 1 over 2 is 4. So let's stop right there. The exponent is the same for all of these. And you might have noticed a pattern. Square root of 4 is 2. Square root of 9 is 3. The square root of 16 is 4. So I know that an exponent of a half is the same as square root. Now what about this one? 8 to the exponent 1 over 3 is 2. Well, if 1 over 2 is the square root, 1 over 3 is something that we call the cubed root. And I don't know if you can see it, but I actually, on my calculator, I have a cubed button, but the second function of that is the cubed root. So I can actually take a cubed root. Now, a cubed root simply means you're looking for the number that multiplied by itself 3 times gets you 8 in this case. So that's why my answer is 2, because 2 times 2 times 2 is 8. The cubed root of 8 is 2. Now the reason I bring this up is because I want to show you that you can write certain expressions in 2 different ways. You can write the exponent form, or you can write what's called the radical form. So radical just means you're involving some sort of a square root or a cubed root or a fourth or a fifth root, whatever. And you can rewrite that as a power with a fraction, a rational exponent. Okay, so just some terminology here. If you have a number with like the square root type symbol, that's called a radical. The radicand is the number that's underneath the root sign, and this number that goes up here is called the index. So n, for an index of n, the nth root of x, I guess you could say, is equal to x to the exponent 1 over n. So, for example, the cubed root of 8 in radical form, I can rewrite that in exponent form by saying 8 to the exponent 1 over 3. Or if I wanted the fourth root of 16, I could write that as 16 to the exponent 1 over 4. Now, why is this useful? Well, let's say you wanted to know the fourth root of 16, for example. So what number multiplied by itself 4 times gets you 16? Well, that you might have difficulty figuring that out if it's not a straightforward answer. But you probably can't type this into your calculator unless you have a really nice one. You can't type the fourth root of a number. But you can type this into your calculator if you know that you can write it as a rational exponent. So I can type 16 to the exponent 1 over 4 in my calculator. I might not be able to type the fourth root of 16 in my calculator. So this is good to know so that you can actually do calculations without taking too much effort. Now what about this? Okay, I've got the fourth root of something, but that's in here. It's a to the exponent 3. So I've got another exponent. This is getting confusing. Well, let's just think this through. I know that a number, the fourth root of a number is that number with an exponent of 1 over 4. So whatever's in here has an exponent of 1 over 4. So I can write that as a cubed to the exponent 1 over 4. Now I have a power of a power, and I can simplify this because I know if I have a power of a power, I just have to multiply the two exponents together. So 3 times 1 over 4 is 3 over 4. So this is actually simplified as a to the exponent 3 over 4. So here's my summary of rational exponents. Remember, rational, the root of the word is ratio, which refers to a fraction. So a rational exponent is an exponent that is a fraction. Okay, so if I have a power with a rational exponent, I can switch between exponential form and radical form like this. So up here, a to the exponent 3 over 4 is the same as the fourth root of a to the exponent 3. So whatever your base is, the numerator of your exponent stays as the exponent on your base. The denominator of your exponent becomes the index to tell you what kind of root you're taking. Now we're going to work through this with some examples. Hopefully by the end of the examples you'll be more comfortable with this. All right, write in radical form. So here I have a rational exponent of 5 over 2. 2 to the exponent 5 over 2. Well, remember, the denominator of the fraction in your exponent tells you the index of your radical form. So my index is 2. So it's the second root of 2 to the exponent 5. Now, second root, well, that's just a square root, so I don't have to write the 2 there as the index. Standard notation, you don't have to put it. If you just see the root sign with no index, it means it's a square root. So this is the square root of 2 to the exponent 5. Over here, 7 to the exponent 10 over 11. Well, 11 is the index of my radical. And inside, the radicand is 7 to the exponent 10. Now we're going the other way. Here I have the radical form. I want to write it in exponent form. So I've got 2 to the 9 as my radicand. My index is 5. So I can rewrite this as 2 to the 9 over 5. That's my exponent. Over here, 3 to the exponent 3. My index is 100 on my radical. So I have 3 to the exponent 3 over 100. That's the exponent form. Now these, I doubt you can do these in your calculator as it's written. So this is where I was talking about. You need to be able to turn these radical forms into the exponential form so that you can actually do the calculation in your calculator. So for the first one, I know this can be written as 7 to the exponent 2 over 9. So you need to be careful when you type that into your calculator. You'll have to type 7, press your exponent button, and then remember, in brackets, write 2 divided by 9, and then close your brackets, hit equals, and you're going to get something, I'm going to say it's approximately equal to 1.541. I rounded it there. The next one, 1,000 to the exponent 5 over 12. I can type that into my calculator. So I type 1,000, press the exponent button, in brackets 5 divided by 12, and it's going to be approximately 17.783. Okay, so you probably can't type radical form with an index of 12 into your calculator unless you have a really fancy calculator, but you can work around this. You can write it as a power with a rational exponent, and you can get the desired answer. All right, here's some practice simplifying. I've got 1 over the square root of 5a to the exponent 3. So I'm going to simplify this by getting rid of the radical and turning it into exponential form. So the first thing I'm going to do is take this square root and turn it into an exponent of 1 over 2. Now that whole thing is still being cubed, so now I have a power of a power. I can multiply those exponents together. 1 over 2 times 3 is 3 over 2. So I have 1 over 5a to the exponent 3 over 2. Okay, so I changed the whole thing into exponent form, so I'm done. And here in this next example, I'm still asked to do the same thing. I just have a more complex expression here. Okay, but I'm just going to use my exponent rules. So I've got this fraction multiplied by this term here. I have multiplying powers with the same base, so I can add those exponents together. Negative 1 plus 3 over 2. If you have a little trouble with that, you can do some work off to the side. Negative 1 plus 3 over 2. Well, it's kind of the math teacher way would be to get a common denominator here. So this would be negative 2 over 2 plus 3 over 2. And then you have negative 2 plus 3, which is positive 1. So that's half, or 1 over 2. But then there's just the kind of reasoning method, I guess is what you would say. So this is negative 1 plus, well, 3 over 2 is 1.5. So I have negative 1 plus 1 is 0. and a half, well, that puts me up to a half, okay? So that's just working with fractions. Regardless, we can simplify this expression a little bit more. Okay, so -1 plus 3 over 2 is 1 over 2, like I said. So my numerator is a to the 1 over 2 times b to the half, okay? My denominator, a to the exponent 2 to the exponent 1 over 3. Power of a power, multiply my exponents. 2 times 1/3 is 2/3. Okay, now I have powers with the same base, and I'm dividing them. So now I have to subtract the exponents. 1/2 minus 2/3. Again, you might have trouble with the adding and subtracting fractions, so you can feel free to do some work off to the side. 1/2 minus 2/3, you need to have a common denominator. So I made the denominator 6, so if 2 becomes 6, I've multiplied it by 3, so I have to multiply 1 by 3. So 1 over 2 half is 3/6. 2/3 is 4/6. 3/6 minus 4/6 is minus 1/6. 3 minus 4 is minus 1. Okay, so all that to say, when I simplify this here, a to the half divided by a to the 2/3, I end up with a to the negative 1/6. And just to clean this up, I don't like having negative exponents. So remember, if you have a negative exponent in the numerator, you can just have the positive exponent in the denominator. So I can end up with b to the half over a to the 1/6. Now this is my very last example for this lesson. I would like you to try this on your own and check in to see how you do. So pause the video, try this, and then check my solutions, and I'll explain. So this is how I attacked this problem. Here I have power of a power. So multiply the exponents. 5/3 times 3/4. 5 times 3 is 15 in the numerator. 3 times 4 is 12 in the denominator. Do the same here. b to the exponent -4 over 3 to the exponent 3 over 4. -4 times 3 is -12. 3 times 4 is 12. So I have -12 over 12, which is just -1. I left the denominator the same for now. Now I notice I'm dividing powers with the same base, which means I subtract the exponents. So my exponent on a is 15 over 12 minus -1/2. And I have b to the -1 divided by b to the 5/3. So I subtract the exponents. -1, subtract 5/3. Okay, so 15/12 minus -1/2 is the same as 15/12 plus 1/2. To add and subtract fractions, you need a common denominator. So 1/2 is just 6/12. Now they both have 12 as the denominator. 15 plus 6 is 21. So this is 21/12 as the exponent for A. If I look at the exponent for B, -1 minus 5/3. Well, -1 is just -3 over 3. So -3/3 minus 5/3, -3 minus 5 is -8. So I have -8/3 as the exponent on B. This is a negative exponent, so I want to clean this whole expression up by not having a negative exponent. So I'm going to put the positive exponent on the base in the denominator. So take the reciprocal of the base, so instead of b, it's 1 over b, and then the exponent is now positive. So I end up with a to the 21/12 divided by b to the 8/3. So there you have it. This was a long lesson. We talked about the exponent laws for multiplying powers with the same base, dividing powers with the same base, power of a power, zero and negative exponents. We also looked at rational exponents and how you can turn those between the exponent form and the radical form. And then we did some practice. So hopefully this makes sense. If not, ask me questions that you may have. Move on to the practice questions and let me know if you have any problems so I can help.